you have a function f of t that's 1 between 0 and 2, and it's t squared plus 1 between 2 and 4, and it's t cubed after 4. So you're like, okay, look, I would like to Laplace transform this thing. You could do this by writing down the integral and breaking it into a bunch of pieces like Anna has going over here. And eventually, when you're done 37 chunks, you'll get to an answer. It's not a bad approach. Will definitely work eventually. Right? So, totally an option. A different option would be to use unit step functions to write this thing a little bit differently. You guys with me?
Sure.
So, it's 1 kind of normally, right? So I'm thinking to myself, okay, so f is 1 to start with, right? And then at time 2, it's 1 and then also t squared, right? You guys see that? So at time 2, I need a light switch. So here's a light switch that turns on at time 2. And then what do I want to turn on at time 2?
T squared plus 1.
Yeah, you could turn on t squared plus 1, but it was already 1. You guys see that?
Just t squared?
Yeah, so I could just turn on t squared. You guys see that? Another way you could think about that is you could turn on t squared plus 1 and turn off.
I feel like I like that better.
Yeah, no, I don't like that.
Right, so some people are all with the like, okay, it went from 1 to t squared plus 1. Right, so I should turn off what was going before and turn on the new thing. That's actually what you definitely need to do between these two. Right, so when do I need to flip a light switch on another function?
At 4.
Okay, at 4. So I get my light switch out for 4. Oops. U of t minus 4, right?
Mm-hmm.
So I want this to happen at positive 4. What do I need to turn on?
So t cubed.
Okay, I need to turn t cubed on. And what do I need to turn off?
T squared plus 1.
Good. So u of t minus 4 times t squared plus 1. Right, so we start at 1, and then at time 2 we turn on t squared plus 1, and we turn off what was on before.
And then you Laplace that, right?
And then we turn at time 4 t cubed on, and we turn off t squared plus 1. And then if I want to Laplace transform f, I can Laplace transform this junk, which looks like a total disaster, but it actually isn't so bad because there's a formula for this, so you just do it.
And can you only have this when they're like connecting like that?
Yeah, so
Right?
you really only want to do this when there's several pieces, right? So this is a trick for Laplace transforming piecewise functions. If they're defined in 37 pieces, you're going to have a lot of stuff, but none of it's going to be particularly hard.
Okay.
Right? If they're just defined in a couple pieces, it's pretty easy. Cool.
Okay.
And then Laplace transforming, right? You do the Laplace transform of 1 and the Laplace transform of u of t minus 2 times t squared plus 1 and subtract the Laplace transform of u of t minus 2 and so forth. You guys got the other two?
Yeah.
You especially want to do this when it's a pain to integrate the function times e negative st.
Yeah, and you definitely want to do this anytime you have a high power of t, right? Because there's a formula for that in the table, which makes it an easy Laplace transform, and it's just a bunch of integration by parts if you don't have it.
So
Or like
basically
the
try to
trade
get into
function.
Laplace transforms rather than do the integrals.
Yeah, it's much easier to look Laplace transforms up in the table than it is to solve all these integrals, because the integrals are going to be a bunch of integration by parts tricks, right? None of them are hard, there's just a bunch of integration by parts. Whereas looking it up in the table is a pretty slick solution. I don't have to do integration by parts 47 times.
Yeah,
Sure.
that makes sense.
Cool?
Cool.
Okay.